validation, data binding, and type conversion. There are pros and cons for considering validation as business logic, and Spring offers a design for validation and data binding that does not exclude either one of them. Specifically, validation should not be tied to the web tier and should be easy to localize, and it should be possible to plug in any available validator. Considering these concerns, Spring provides a validator contract that is both basic and eminently usable in every layer of an application. Data binding is useful for letting user input be dynamically bound to the domain model of an application, or whatever objects you use to process user input. Spring provides the aptly named data binder to do exactly that. The validator and the data binder make up the validation package, which is primarily used in but not limited to the web layer. The bin wrapper is a fundamental concept in the Spring framework and is used in a lot of places. However, you probably do not need to use the bin wrapper directly. Because this is reference documentation, however, we feel that some explanation might be in order. We explain the bin wrapper in this chapter, since, if you are going to use it at all, you are most likely do so when trying to bind data to objects. Spring's data binder and the lower-level bin wrapper both use property editor support implementations to parse and format property values. The property editor and property editor support types are part of the Java Beans specification and are also explained in this chapter. Spring's core.convert package provides a general type conversion facility, as well as a higher-level format package for formatting UI field values. You can use these packages as simpler alternatives to property editor support implementations. They are also discussed in this chapter. Spring supports Java Bin validation through setup infrastructure and an adapter to Spring's own validator contract. Applications can enable bin validation once globally, as described in Java Bin validation, and use it exclusively for all validation needs. In the web layer, applications can further register controller local Spring validator instances per data binder, as described in configuring a data binder, which can be useful for plugging in custom validation logic. Validation by using Spring's validator interface. Spring features a validator interface that you can use to validate objects. The validator interface works by using an errors object so that, while validating, validators can report validation failures to the errors object. Consider the following example of a small data object. Public class person. Private string name, private int age. / the usual getters and setters. The next example provides validation behavior for the person class by implementing the following two methods of the org.springframework.validation.validator interface. 1. Supports class. Can this validator validate instances of the supplied class? 2. Validate object. org.springframework.validation.errors validates the given object and, in case of validation errors, registers those with the given errors object. Implementing a validator is fairly straightforward, especially when you know of the validation utils helper class that the Spring framework also provides. The following example implements validator for person instances. Public class person validator implements validator. This validator validates only person instances. Public boolean supports class. Return person.class.equals class. Public void validate object obj, errors e. Validation utils.reject if empty e, name.empty, person p equals, person, obj, if, p.get age less than 0. E.reject value age, negative e value, else if, p.get age greater than 110. E.reject value age, 2.darn.old. The static reject if empty, Method on the validation utils class is used to reject the name property if it is null or the empty string. Have a look at the validation utils Javadoc to see what functionality it provides besides the example shown previously. While it is certainly possible to implement a single validator class to validate each of the nested objects in a rich object, it may be better to encapsulate the validation logic for each nested class of object in its own validator implementation. A simple example of a rich object would be a customer that is composed of two string properties, a first and a second name, and a complex address object. Address objects may be used independently of customer objects, so a distinct address validator has been implemented. If you want your customer validator to reuse the logic contained within the address validator class without resorting to copy and paste, you can dependency inject or instantiate an address validator within your customer validator, as the following example shows. Public class customer validator implements validator. Private final validator address, validator. Public customer validator validator address validator. If address validator equals null, throw new illegal argument exception the supplied validator is plus required and must not be null. If address validator supports address.class, throw new illegal argument exception the supplied validator must plus support the validation of address instances. This address validator equals address validator / this validator validates customer instances and any subclasses of customer too. Public boolean supports class. Return customer.class. Is assignable from class. Public void validate object target errors. Validation utils. Reject if empty or whitespace errors. First name field. Required. Validation utils. Reject if empty or whitespace errors. Surname field. Required. Customer equals customer target try errors. Push nested path address validation utils. Invoke validator this. Address validator customer.get address errors. Finally errors. Pop nested path. Validation errors are reported to the errors object passed to the validator. In the case of Spring Web MVC, you can use the Spring Bind tag to inspect the error messages, but you can also inspect the errors object yourself. More information about the methods it offers can be found in the Javadoc. Validators may also get locally invoked for the immediate validation of a given object, not involving a binding process. As of 6.1, this has been simplified through a new validator.validate object method which is available by default now, returning a simple errors representation which can be inspected, typically calling has errors or the new fail on error method for turning the error summary message into an exception, for example validator.validate object my object. Fail on error illegal argument exception : new. Resolving codes to error messages. We covered data binding and validation. This section covers outputting messages that correspond to validation errors. In the example shown in the preceding section, we rejected the name and age fields. If we want to output the error messages by using a message source, we can do so using the error code we provide when rejecting the field, name and age in this case. When you call, either directly or indirectly, by using, for example, the validation utils class, reject value or one of the other reject methods from the errors interface, the underlying implementation not only registers the code you passed in but also registers a number of additional error codes. The message codes resolver determines which error codes the errors interface registers. By default, the default message codes resolver is used, which, for example, not only registers a message with the code you gave but also registers messages that include the field name you passed to the reject method. So, if you reject a field by using reject value age, 2.dan.old, apart from the 2.dan.old code, Spring also registers 2.dan.old.age and 2.dan.old.age.int. The first includes the field name and the second includes the type of the field. This is done as a convenience to aid developers when targeting error messages. More information on the message codes resolver and the default strategy can be found in the Java doc of message codes resolver and default message codes resolver, respectively. Data binding. Data binding is useful for binding user input to a target object where user input is a map with property paths as keys, following Java Beans conventions. Data binder is the main class that supports this, and it provides two ways to bind user input. 1. Constructor binding. Bind user input to a public data constructor, looking up constructor argument values in the user input. 2. Property binding. Bind user input to setters, matching keys from the user input to properties of the target object structure. You can apply both constructor and property binding or only one. Constructor binding. 1. Create a data binder with null as the target object. 2. Set target type to the target class. 3. Call construct. The target class should have a single public constructor or a single non-public constructor with arguments. If there are multiple constructors, then a default constructor if present is used. By default, constructor parameter names are used to look up argument values, but you can configure name resolver. Spring MVC and WebFlux both rely to allow customizing the name of the value to bind through an @bindParam annotation on constructor parameters. Type conversion is applied as needed to convert user input. If the constructor parameter is an object, it is constructed recursively in the same manner, but through a nested property path. That means constructor binding creates both the target object and any objects it contains. Binding and conversion errors are reflected in the binding result of the data binder. If the target is created successfully, then target is set to the created instance after the call to construct. Property binding with bin wrapper. The org.springframework.beans package adheres to the Java Beans standard. A Java bin is a class with a default no-argument constructor and that follows a naming convention where, for example, a property named Bingo Madness would have a setter method set Bingo Madness and a getter method get Bingo Madness. For more information about Java Beans and the specification, see Java Beans. One quite important class in the Beans package is the bin wrapper interface and its corresponding implementation, bin wrapper impl. As quoted from the Java doc, the bin wrapper offers functionality to set and get property values, individually or in bulk, get property descriptors, and query properties to determine if they are readable or writable. Also, the bin wrapper offers support for nested properties, enabling the setting of properties on sub-properties to an unlimited depth. The bin wrapper also supports the ability to add standard Java Beans property change listeners and vetoable change listeners, without the need for supporting code in the target class. Last but not least, the bin wrapper provides support for setting indexed properties. The bin wrapper usually is not used by application code directly but is used by the data binder and the bin factory. The way the bin wrapper works is partly indicated by its name. It wraps a bin to perform actions on that bin, such as setting and retrieving properties. Setting and getting basic and nested properties. Setting and getting properties is done through the setPropertyValue and getPropertyValue overloaded method variants of bin wrapper. See their Java doc for details. The below table shows some examples of these conventions. Name indicates the property name that corresponds to the getName or isName and setName methods. Account.name indicates the nested property name of the property account that corresponds to, for example, the getAccount. SetName or getAccount. GetName methods. Account2 indicates the third element of the indexed property account. Indexed properties can be of type array, list, or other naturally ordered collection. Account company name indicates the value of the map entry indexed by the company name key of the account map property. This next section is not vitally important to you if you do not plan to work with the bin wrapper directly. If you use only the data binder and the bin factory and their default implementations, you should skip ahead to the section on property editors. The following two example classes use the bin wrapper to get and set properties. Public class company. Private string name, private employee managing director. Public string get name, return this .name. Public void set name string name, this .name equals name. Public employee get managing director, return this .managing director. Public void set managing director employee managing director. This .managing director equals managing director. Public class employee. Private string name. Private float salary. Public string get name, return this .name. Public void set name string name. This .name equals name. Public float get salary, return salary. Public void set salary float salary. This .salary equals salary. The following code snippets show some examples of how to retrieve and manipulate some of the properties of instantiated companies and employees. Bin wrapper company equals new bin wrapper impl new company / setting the company name. Company.set property value name, some company incorporated / can also be done like this. Property value equals new property value name, some company incorporated, company.set property value value. / OK, let's create the director and tie it to the company. Bin wrapper Jim equals new bin wrapper impl new employee, Jim.set property value name, Jim Stravinsky, company.set property value managing director, Jim.get wrapped instance. / retrieving the salary of the managing director through the company. Float salary equals float, company.get property value managing director.salary. Property editors. Spring uses the concept of a property editor to effect the conversion between an object and a string. It can be handy to represent properties in a different way than the object itself. For example, a date can be represented in a human-readable way, as the string 2007-1409, while we can still convert the human-readable form back to the original date, or, even better, convert any date entered in a human-readable form back to date objects. This behavior can be achieved by registering custom editors of type java.beans.propertyEditor. Registering custom editors on a bin wrapper or, alternatively, in a specific IOC container, as mentioned in the previous chapter, gives it the knowledge of how to convert properties to the desired type. For more about property editor, see the Java doc of the java.beans package from Oracle. A couple of examples where property editing is used in Spring. 1. Setting properties on Beans is done by using property editor implementations. When you use string as the value of a property of some bin that you declare in an XML file, Spring, if the setter of the corresponding property has a class parameter, uses class editor to try to resolve the parameter to a class object. 2. Parsing HTTP request parameters in Spring's MVC framework is done by using all kinds of property editor implementations that you can manually bind in all subclasses of the command controller. Spring has a number of built-in property editor implementations to make life easy. They are all located in the org.springframework.beans.propertyeditors package. Most, but not all, as indicated in the following table, are, by default, registered by bin wrapper impl. Where the property editor is configurable in some fashion, you can still register your own variant to override the default one. The following table describes the various property editor implementations that Spring provides. Byte, array, property, editor. Editor for byte arrays. Convert strings to their corresponding byte representations. Registered by default by bin wrapper impl. Class, editor. Parses strings that represent classes to actual classes and vice versa. When a class is not found, an illegal argument exception is thrown. By default, registered by bin wrapper impl. Custom, Boolean, editor. Customizable property editor for Boolean properties. By default, registered by bin wrapper impl but can be overridden by registering a custom instance of it as a custom editor. Custom, collection, editor. Property editor for collections, converting any source collection to a given target collection type. Custom, date, editor. Customizable property editor for java.util.date, supporting a custom date format. Not registered by default. Must be user registered with the appropriate format as needed. Custom, number, editor. Customizable property editor for any number subclass, such as integer, long, float, or double. By default, registered by bin wrapper impl but can be overridden by registering a custom instance of it as a custom editor. File, editor. Resolve strings to java.io. File objects. By default, registered by bin wrapper impl. Input, stream, editor. One-way property editor that can take a string and produce, through an intermediate resource editor and resource, an input stream so that input stream properties may be directly set as strings. Note that the default usage does not close the input stream for you. By default, registered by bin wrapper impl. Locale, editor. Can resolve strings to locale objects and vice versa. The string format is language_country_variant, same as the toString method of locale. Also accepts spaces as separators, as an alternative to underscores. By default, registered by bin wrapper impl. Pattern, editor. Can resolve strings to java.util.regex.pattern objects and vice versa. Properties, editor. Can convert strings, formatted with the format defined in the Java doc of the java.util.properties class, to properties objects. By default, registered by bin wrapper impl. String, trimmer, editor. Property editor that trims strings. Optionally allows transforming an empty string into a null value. Not registered by default, must be user registered. EL editor. Can resolve a string representation of a URL to an actual URL object. By default, registered by bin wrapper impl. Spring uses the java.beans.property editor manager to set the search path for property editors that might be needed. The search path also includes sun.bin.editors, which includes property editor implementations for types such as font, color, and most of the primitive types. Note also that the standard Java Beans infrastructure automatically discovers property editor classes, without you having to register them explicitly, if they are in the same package as the class they handle and have the same name as that class, with editor appended. For example, one could have the following class and package structure, which would be sufficient for the something editor class to be recognized and used as the property editor for something typed properties. Shank, pop, something editor / the property editor for the something class. Note that you can also use the standard bin-info Java Beans mechanism here as well, described to some extent here. The following example uses the bin-info mechanism to explicitly register one or more property editor instances with the properties of an associated class. Shank, pop, something bin-info / the bin-info for the something class. The following Java source code for the referenced something bin-info class associates a custom number editor with the age property of the something class. Public class something bin-info extends simple bin info. Public property descriptor get property descriptors try final property editor number equals new custom number editor integer.class true. Property descriptor age descriptor equals new property descriptor age, something.class. Add override. Public property editor create property editor object bin. Return number. Return new property descriptor, age, descriptor. Catch, introspection exception x. Throw new error x.to. String. Custom property editors. When setting bin properties as string values, a Spring IOC container ultimately uses standard Java Beans property editor implementations to convert these strings to the complex type of the property. Spring pre-registers a number of custom property editor implementations, for example, to convert a class name expressed as a string into a class object. Additionally, Java's standard Java Beans property editor lookup mechanism lets a property editor for a class be named appropriately and placed in the same package as the class for which it provides support, so that it can be found automatically. If there is a need to register other custom property editors, several mechanisms are available. The most manual approach, which is not normally convenient or recommended, is to use the register custom editor method of the configurable bin factory interface, assuming you have a bin factory reference. Another, slightly more convenient, mechanism is to use a special bin factory post-processor called custom editor configurer. Although you can use bin factory post-processors with bin factory implementations, the custom editor configurer has a nested property setup, so we strongly recommend that you use it with the application context, where you can deploy it in similar fashion to any other bin, and where it can be automatically detected and applied. Note that all bin factories and application contexts automatically use a number of built-in property editors, through their use of a bin wrapper to handle property conversions. The standard property editors that the bin wrapper registers are listed in the previous section. Additionally, application contexts also override or add additional editors to handle resource lookups in a manner appropriate to the specific application context type. Standard Java Beans property editor instances are used to convert property values expressed as strings to the actual complex type of the property. You can use custom editor configurer, a bin factory post-processor, to conveniently add support for additional property editor instances to an application. Context. Consider the following example, which defines a user class called exotic type and another class called depends on exotic type, which needs exotic type set as a property. Package example. Public class exotic type. Private string name. Public exotic type string name. This.name equals name. Public class depends on exotic type. Private exotic type. Public void set type exotic type type. This .type equals type. When things are properly set up, we want to be able to assign the type property as a string, which a property editor converts into an actual exotic type instance. The following bin definition shows how to set up this relationship. The property editor implementation could look similar to the following. // converts string representation to exotic type object. Public class exotic type editor extends property editor support. Public void set as text string text. Set value new exotic type text.to upper case. Finally, the following example shows how to use custom editor configurer to register the new property editor with the application context, which will then be able to use it as needed. org.springframework.beans.factory.config.custom editor configurer property editor registrar. Another mechanism for registering property editors with the Spring container is to create and use a property editor registrar. This interface is particularly useful when you need to use the same set of property editors in several different situations. You can write a corresponding registrar and reuse it in each case. Property editor registrar instances work in conjunction with an interface called Property Editor Registry, an interface that is implemented by the Spring bin wrapper and data binder. Property editor registrar instances are particularly convenient when used in conjunction with custom editor configurer, described here, which exposes a property called set property editor registrars. Property editor registrar instances added to a custom editor configurer in this fashion can easily be shared with data binder and Spring MVC controllers. Furthermore, it avoids the need for synchronization on custom editors. A property editor registrar is expected to create fresh property editor instances for each bin creation attempt. The following example shows how to create your own property editor registrar implementation. packagecom.foo.editors.spring. Public final class custom property editor registrar implements property editor registrar. Public void register custom editors property editor registry. It is expected that new property editor instances are created. Registry.register custom editor exotic type.class new exotic type editor. // you could register as many custom property editors as are required here. See also the org.springframework.beans.support.resource editor registrar for an example property editor registrar implementation. Notice how in its implementation of the register custom editors method, it creates new instances of each property editor. The next example shows how to configure a custom editor configurer and inject an instance of our custom property editor registrar into it. org.springframework.beans.factory.config.custom editor configurer com.foo.editors.spring.custom property editor registrar. Finally, and in a bit of a departure from the focus of this chapter, for those of you using Spring's MVC web framework, using a property editor registrar in conjunction with data binding web controllers can be very convenient. The following example uses a property editor registrar and the implementation of an @init binder method. @controller. Public class register. User. Controller. Private final property editor registrar custom. Property editor registrar. Register user controller property editor registrar. This custom property editor registrar equals property editor registrar. @init binder. Void init binder web data binder. This custom property editor registrar register custom editors binder. // other methods related to registering a user. This style of property editor registration can lead to concise code. The implementation of the @init binder method is only one line long, and lets common property editor registration code be encapsulated in a class and then shared amongst as many controllers as needed. Spring type conversion. The core.convert package provides a general type conversion system. The system defines an SPI to implement type conversion logic and an API to perform type conversions at runtime. Within a Spring container, you can use this system as an alternative to property editor implementations to convert externalized bin property value strings to the required property types. You can also use the public API anywhere in your application where type conversion is needed. Converter SPI. The SPI to implement type conversion logic is simple and strongly typed, as the following interface definition shows. Package org.springframework.core.convert.converter.
Public interface converter S, T.
T-convert S source. To create your own converter, implement the converter interface and parameterize S as the type you are converting from and T as the type you are converting to. You can also transparently apply such a converter if a collection or array of S needs to be converted to an array or collection of T, provided that a delegating array or collection converter has been registered as well, which default conversion service does by default. For each call to converts, the source argument is guaranteed to not be null. Your converter may throw any unchecked exception if conversion fails. Specifically, it should throw an illegal argument exception to report an invalid source value. Take care to ensure that your converter implementation is thread safe. Several converter implementations are provided in the core.convert.support package as a convenience. These include converters from strings to numbers and other common types. The following listing shows the string to integer class, which is a typical converter implementation. Package org.springframework.core.convert.support. Final class string to integer implements converter string, integer. Public integer converts string source. Return integer.value of source. Using converter factory. When you need to centralize the conversion logic for an entire class hierarchy, for example, when converting from string to enum objects, you can implement converter factory, as the following example shows. Package org.springframework.core.convert.converter.
Public interface converter factory S, R. T extends R converter S, T get converter class T target type.
Parameterize S to be the type you are converting from and R to be the base type defining the range of classes you can convert to. Then implement get converter class T where T is a subclass of R. Consider the string to enum converter factory as an example. Package org.springframework.core.convert.support. Final class string to enum converter factory implements converter factory string, enum. Public T extends enum converter string, T get converter class T target type. Return new string to enum converter target type. Private final class string to enum converter T extends enum implements converter string, T. Private class T enum type. Public string to enum converter class T enum type. This .enum type equals enum type. Public T converts string source. Return T enum.value of this .enum type, source.trim. Using generic converter. When you require a sophisticated converter implementation, consider using the generic converter interface. With a more flexible but less strongly typed signature than converter, a generic converter supports converting between multiple source and target types. In addition, a generic converter makes available source and target field context that you can use when you implement your conversion logic. Such context lets a type conversion be driven by a field annotation or by generic information declared on a field signature. The following listing shows the interface definition of generic converter. Package org.springframework.core.convert.converter. Public interface generic converter. Public set convertible pair get convertible. Types: object convert object source, type descriptor source type descriptor target, type. To implement a generic converter, have get convertible types return the supported source target type pairs. Then implement convert object, type descriptor to contain your conversion logic. The source type descriptor provides access to the source field that holds the value being converted. The target type descriptor provides access to the target field where the converted value is to be set. A good example of a generic converter is a converter that converts between a Java array and a collection. Such an array-to-collection converter introspects the field that declares the target collection type to resolve the collection's element type. This lets each element in the source array be converted to the collection element type before the collection is set on the target field. Because generic converter is a more complex SPI interface, you should use it only when you need it. Favor converter or converter factory for basic type conversion needs. Using conditional generic converter. Sometimes, you want a converter to run only if a specific condition holds true. For example, you might want to run a converter only if a specific annotation is present on the target field, or you might want to run a converter only if a specific method, such as a static value of method, is defined on the target class. Conditional generic converter is the union of the generic converter and conditional converter interfaces that lets you define such custom matching criteria. Public interface conditional converter. Boolean matches type descriptor source type descriptor target, type. Public interface conditional generic converter extends generic converter, conditional converter. A good example of a conditional generic converter is an id-to-entity converter that converts between a persistent entity identifier and an entity reference. Such an id-to-entity converter might match only if the target entity type declares a static finder method, for example, findAccountLong. You might perform such a finder method check in the implementation of matches type descriptor, The Conversion Service API. Conversion Service defines a unified API for executing type conversion logic at runtime. Converters are often run behind the following facade interface. Package org.springframework.core.convert. Public interface conversion service. Boolean can convert class less than greater than source type, class less than greater than target type. TT convert object source, class less than T target type. Boolean can convert type descriptor source type descriptor target type. Object convert object source, type descriptor source type descriptor target type. Most conversion service implementations also implement converter registry, which provides an SPI for registering converters. Internally, a conversion service implementation delegates to its registered converters to carry out type conversion logic. A robust conversion service implementation is provided in the core.convert.support package. Generic conversion service is the general-purpose implementation suitable for use in most environments. Conversion Service Factory provides a convenient factory for creating common conversion service configurations. Configuring a conversion service. A conversion service is a stateless object designed to be instantiated at application startup and then shared between multiple threads. In a Spring application, you typically configure a conversion service instance for each Spring container or application context. Spring picks up that conversion service and uses it whenever a type conversion needs to be performed by the framework. You can also inject this conversion service into any of your beans and invoke it directly. If no conversion service is registered with Spring, the original property editor-based system is used. Spring, add the following bin definition with an ID of conversion. Service. org.springframework.context.support.conversion. Service. Factory. Bin. A default conversion service can convert between strings, numbers, enums, collections, maps, and other common types. To supplement or override the default converters with your own custom converters, set the converters property. Property values can implement any of the converter factory, or generic converter interfaces. org.springframework.context.support.conversion. Service. Factory. Bin. It is also common to use a conversion service within a Spring MVC application. See conversion and formatting in the Spring MVC chapter. In certain situations, you may wish to apply formatting during conversion. See the Formatter Registry SPI for details on using formatting. Conversion. Service. Factory. Bin. Using a conversion service programmatically. To work with a conversion service instance programmatically, you can inject a reference to it like you would for any other bin. The following example shows how to do so. @service. Public class my service. Private final conversion service conversion service. Public my service conversion service conversion service. This.conversion service equals conversion service. Public void do it, this.conversion service.convert. For most use cases, you can use the convert method that specifies the target type, but it does not work with more complex types, such as a collection of a parameterized element. For example, if you want to convert a list of integer to a list of string programmatically, you need to provide a formal definition of the source and target types. Fortunately, Type Descriptor provides various options to make doing so straightforward, as the following example shows. Default. Conversion. Service CS equals new default. Conversion. Service. List integer input equals cs.convert input, type descriptor. For object input, / list integer type descriptor. Type descriptor. Collection list.class, type descriptor. Value of string.class. Note that default conversion service automatically registers converters that are appropriate for most environments. This includes collection converters, scalar converters, and basic object-to-string converters. You can register the same converters with any converter registry by using the static add default converters method on the default conversion service class. Converters for value types are reused for arrays and collections, so there is no need to create a specific converter to convert from a collection of S to a collection of T, assuming that standard collection handling is appropriate. Spring field formatting. As discussed in the previous section, core.convert is a general-purpose typed conversion system. It provides a unified conversion service API as well as a strongly typed converter SPI for implementing conversion logic from one type to another. A Spring container uses this system to bind bin property values. In addition, both the Spring Expression Language, SpEL, and Data Binder use this system to bind field values. For example, when SpEL needs to coerce a short to a long to complete an expression.setValue object bin, object value, attempt, the core.convert system performs the coercion. Now consider the type conversion requirements of a typical client environment, such as a web or desktop application. In such environments, you typically convert from string to support the client postback process, as well as back to string to support the view rendering process. In addition, you often need to localize string values. The more general core.convert converter SPI does not address such formatting requirements directly. To directly address them, Spring provides a convenient formatter SPI that provides a simple and robust alternative to property editor implementations for client environments. In general, you can use the converter SPI when you need to implement general-purpose type conversion logic, for example, for converting between a java.util.date and a long. You can use the formatter SPI when you work in a client environment, such as a web application, and need to parse and print localized field values. The conversion service provides a unified type conversion API for both SPIs. The formatter SPI. The formatter SPI to implement field formatting logic is simple and strongly typed. The following listing shows the formatter interface definition. Package org.springframework.format. Public interface formatter (T) extends printer (T) parser (T). Formatter extends from the printer and parser building block interfaces. The following listing shows the definitions of those two interfaces. Public interface printer (T). String print T field value, locale. Public interface parser (T). T parse string client value, locale, throws parse, exception. To create your own formatter, implement the formatter interface shown earlier. Parameterize T to be the type of object you wish to format, for example, java.util.date. Implement the print operation to print an instance of T for display in the client locale. Implement the parse operation to parse an instance of T from the formatted representation returned from the client locale. Your formatter should throw a parse exception or an illegal argument exception if a parse attempt fails. Take care to ensure that your formatter implementation is thread safe. The format subpackages provide several formatter implementations as a convenience. The number package provides number style formatter, currency style formatter, and %style formatter to format number objects that use a java.text.number format. The datetime package provides a date formatter to format java.util.date objects with a java.text.date format. The following date formatter is an example formatter implementation. Package org.springframework.format.datetime. Public final class date formatter implements formatter date. Private string pattern. Public date formatter string pattern. This pattern equals pattern. Public string print date, locale. If date equals null, return. Return get date format locale. Format date. Public date parse string formatted, locale, throws parse exception, if formatted.length equals 0. Return null. Return get date format locale. Parse formatted. Protected date format get date format locale. Date format equals new simple date format this dot pattern locale date format dot set lenient false return date format. The Spring team welcomes community-driven formatter contributions. See GitHub issues to contribute. Annotation-driven formatting. Field formatting can be configured by field type or annotation. To bind an annotation to a formatter, implement Annotation Formatter Factory. The following listing shows the definition of the Annotation Formatter Factory interface. Package org.springframework.format. Public interface Annotation Formatter Factory extends annotation. Set class get field types. Printer greater than get printer annotation class greater than field type. Parser greater than get parser annotation class greater than field type. 1. Parameterize A to be the field annotation type with which you wish to associate formatting logic, for example org.springframework.format.annotation.date time format. 2. Have get field types return the types of fields on which the annotation can be used. 3. Have get printer return a printer to print the value of an annotated field. 4. Have get parser return a parser to parse a client value for an annotated field. The following example Annotation Formatter Factory implementation binds the @number format annotation to a formatter to let a number style or pattern be specified. Public final class number format Annotation Formatter Factory implements Annotation Formatter Factory number format. Private static final set class field underscore types equals set dot of short dot class, integer dot class, long dot class, float dot class, double dot class, big decimal dot class, big integer dot class. Public set class get field types, return field underscore types. Public printer number get printer number format annotation class greater than field type. Return configure formatter from annotation field type. Public parser number get parser number format annotation class greater than field type. Return configure formatter from annotation field type. Formatter from number format annotation class greater than field type. If !annotation.pattern is empty, return new number style formatter annotation.pattern. / else. Return switch annotation.style. Case style.percent greater than new percent style formatter. Case style.currency greater than new currency style formatter. Default greater than new number style formatter. To trigger formatting, you can annotate fields with @number format, as the following example shows. Public class my model @number format style equals style.currency private big decimal format annotation API. API exists in the org.springframework.format.annotation package. You can use @number format to format number fields such as double and long, and @datetime format to format java.util.date, java.util.calendar, long, for millisecond timestamps, as well as JSR 310 java.time. The following example uses @datetime format to format a java.util.date as an ISO date, YMMDD. Public class my model @date time Format ISO equals ISO.date private date. The formatter registry SPI. The formatter registry is an SPI for registering formatters and converters. Formatting Conversion Service is an implementation of formatter registry suitable for most environments. You can programmatically or declaratively configure this variant as a Spring bin, for example by using Formatting Conversion Service Factory bin. Because this implementation also implements Conversion Service, you can directly configure it for use with Spring's data binder and the Spring Expression Language (SpEL). The following listing shows the formatter registry SPI. Package org.springframework.format. Public Interface Formatter Registry extends Converter Registry. Void add printer less than greater than printer. Void add parser less than greater than parser. Void add formatter less than greater than formatter. Void add formatter for field type class less than greater than field type, formatter less than greater than formatter. Void add formatter for field type class less than greater than field type, printer less than greater than printer, parser less than greater than parser. Void add formatter for field annotation formatter factory less than extends annotation formatter factory. As shown in the preceding listing, you can register formatters by field type or by annotation. The formatter registry SPI lets you configure formatting rules centrally, instead of duplicating such configuration across your controllers. For example, you might want to enforce that all date fields are formatted a certain way or that fields with a specific annotation are formatted in a certain way. With a shared formatter registry, you define these rules once, and they are applied whenever formatting is needed. The Formatter Registrar SPI. Formatter Registrar is an SPI for registering formatters and converters through the formatter registry. The following listing shows its interface definition. Package org.springframework.format. Public Interface Formatter Registrar. Void Register Formatters Formatter Registry. A formatter registrar is useful when registering multiple related converters and formatters for a given formatting category, such as date formatting. It can also be useful where declarative registration is insufficient, for example, when a formatter needs to be indexed under a specific field type different from its own T, or when registering a printer/parser pair. The next section provides more information on converter and formatter registration. Configuring formatting in Spring MVC. See Conversion and Formatting in the Spring MVC chapter. Configuring a global date and time format. By default, date and time fields not annotated with a date-time format are converted from strings by using the date format.short style. If you prefer, you can change this by defining your own global format. To do that, ensure that Spring does not register default formatters. Instead, register formatters manually with the help of 1. org.springframework.format.datetime.standard.datetime formatter registrar. 2. org.springframework.format.datetime.date formatter registrar. For example, the following Java configuration registers a global YAML format. At configuration. Public class app. Config. At bin. Public formatting conversion service conversion. Service. / use the default formatting conversion service but do not register defaults. Default formatting conversion service equals new default formatting conversion service false. / ensure number format is still supported. Conversion service.add formatter for field annotation new number. format, annotation, formatter, factory, / register JSR 310 date conversion with a specific global format. Datetime formatter registrar datetime registrar equals new datetime formatter registrar datetime registrar.set date formatter datetime formatter.of pattern yimd datetime registrar.register formatters conversion service / register date conversion with a specific global format. Date formatter registrar equals new date formatter registrar date registrar.set formatter new date formatter yimd date registrar.register formatters conversion service return conversion service. If you prefer XML-based configuration, you can use a formatting conversion service factory bin. The following example shows how to do so. http URL org.springframework.format.support.formatting conversion service factory bin org.springframework.format.number format annotation formatter factory org.springframework.format.datetime.standard.date time formatter registrar org.springframework.format.datetime.standard.date time formatter factory bin. Note there are extra considerations when configuring date and time formats in web applications. Please see Web MVC conversion and formatting or Web Flux conversion and formatting. Java bin validation. The Spring Framework provides support for the Java bin validation API. Overview of bin validation. Bin validation provides a common way of validation through constraint declaration and metadata for Java applications. To use it, you annotate domain model properties with declarative validation constraints which are then enforced by the runtime. There are built-in constraints, and you can also define your own custom constraints. Consider the following example, which shows a simple person form model with two properties. Public class person form, private string name, private int age. Bin validation lets you declare constraints as the following example shows. Public class person form at not null at size max equals 64 private string name at min 0 private int age. A bin validation validator then validates instances of this class based on the declared constraints. See bin validation for general information about the API. See the Hibernate Validator documentation for specific constraints. To learn how to set up a bin validation provider as a Spring bin, keep reading. Configuring a bin validation provider. Spring provides full support for the bin validation API, including the bootstrapping of a bin validation provider as a Spring bin. This lets you inject a Jakarta.validation.validator factory or Jakarta.validation.validator wherever validation is needed in your application. You can use the local validator factory bin to configure a default validator as a Spring bin, as the following example shows. Import org.springframework.validation.binvalidation.local validator factory bin. At configuration. Public class app config at bin. Public local validator factory bin validator return new local validator factory bin. The basic configuration in the preceding example triggers bin validation to initialize by using its default bootstrap mechanism. A bin validation provider, such as the Hibernate Validator, is expected to be present in the class path and is automatically detected. Inject Jakarta Validator. Local Validator Factory bin implements both Jakarta.validation.validator and Jakarta.validation.validator, so you can inject a reference to the latter to apply validation logic if you prefer to work with the bin validation API directly, as the following example shows. @Service. Public class my service. @AutoWired. Private validator. Inject Spring Validator. In addition to implementing Jakarta.validation.validator, Local Validator Factory bin also adapts to org.springframework.validation.validator, so you can inject a reference to the latter if your bin requires the Spring Validation API. @Service. Public class my service. @AutoWired. Private validator. When used as org.springframework.validation.validator, Local Validator Factory bin invokes the underlying Jakarta.validation.validator, and then adapts content violations to field errors, and registers them with the errors object passed into the validate method. Configure custom constraints. Each bin validation constraint consists of two parts. 1. A constraint annotation that declares the constraint and its configurable properties. 2. An implementation of the Jakarta.validation.constraint validator interface that implements the constraint's behavior. To associate a declaration with an implementation, each constraint annotation references a corresponding constraint validator implementation class. At runtime, a constraint validator factory instantiates the referenced implementation when the constraint annotation is encountered in your domain model. By default, the local validator factory bin configures a Spring constraint validator factory that uses Spring to create constraint validator instances. This lets your custom constraint validators benefit from dependency injection like any other Spring bin. The following example shows a custom constraint declaration followed by an associated constraint validator implementation that uses Spring for dependency injection. At target element type.method, element type.field, at retention policy.runtime at constraint validated by equals my constraint validator.class public at interface my constraint. Public class my constraint validator implements constraint validator. At AutoWired, private foo a dependency // As the preceding example shows, a constraint validator implementation can have its dependencies at AutoWired as any other Spring bin. Spring-driven method validation. You can integrate the method validation feature of bin validation into a Spring context through a method validation post-processor bin definition. Import org.springframework.validation.bin validation.method validation post processor. At configuration. Public class app config. At bin. Public method validation post-processor return new method validation post-processor. To be eligible for Spring-driven method validation, target classes need to be annotated with Spring's @validated annotation, which can optionally also declare the validation groups to use. See method validation post-processor for setup details with the Hibernate validator and bin validation providers. Method validation relies on AOP proxies around the target classes, either JDK dynamic proxies for methods on interfaces or PLIB proxies. There are certain limitations with the use of proxies, some of which are described in Understanding AOP Proxies. In addition, remember to always use methods and accessors on proxied classes. Direct field access will not work. Spring MVC and WebFlux have built-in support for the same underlying method validation, but without the need for AOP. Therefore, do check the rest of this section, and also see the Spring MVC validation and error responses sections, and the WebFlux validation and error responses sections. Method validation exceptions. By default, Jakarta.validation.constraint violation exception is raised with the set of constraint violations returned by Jakarta.validation.validator. As an alternative, you can have method validation exception raised instead with constraint violations adapted to message source resolvable errors. To enable, set the following flag. Import org.springframework.validation.bean validation.method validation post processor at configuration public class app config at bin public method validation post processor method validation post processor equals new method validation post processor processor.set adapt constraint violations true return processor. Method validation exception contains a list of parameter validation results which group errors by method parameter, and each exposes a method parameter, the argument value, and a list of message source resolvable errors adapted from constraint violations. For at valid method parameters with cascaded violations on fields and properties, the parameter validation result is parameter errors, which implements org.springframework.validation.errors and exposes validation errors as field errors. Customizing validation errors. The adapted message source resolvable errors can be turned into error messages to display to users through the configured message source with locale and language-specific resource bundles. This section provides an example for illustration. Record person at size min equals 1, max equals 10, string name. At validated. Public class my service. Void add student at valid person at max 2 int degrees // A constraint violation on person.name is adapted to a field arrow with the following. 1. Error code size.student.name, size.name, size.java.lang.string, and size. 2. Message arguments name, 10, and 1, the field name and the constraint attributes. 3. Default message size must be between 1 and 10. To customize the default message, you can add properties to message source resource bundles using any of the above errors codes and message arguments. Note also that the message argument name is itself a messenger source resolvable with error code student.name and can customize too. For example, properties. Size.student.name equals please provide a 0 that is between 2 and 1 characters long. Student.name equals username. A constraint violation on the degrees method parameter is adapted to a message source resolvable with the following. 1. Error codes max.myService hash add student.degrees, max.degrees, max.int, max. 2. Message arguments degrees 2 and 2, the field name and the constraint attribute. 3. Default message must be less than or equal to 2. To customize the above default message, you can add a property such as properties. Max.degrees equals you cannot provide more than 1. 0 additional configuration options. The default local validator factory bin configuration suffices for most cases. There are a number of configuration options for various bin validation constructs, from message interpolation to traversal resolution. See the local validator factory bin Java doc for more information on these options. Configuring a data binder. You can configure a data binder instance with a validator. Once configured, you can invoke the validator by calling binder.validate. Any validation errors are automatically added to the binder's binding result. The following example shows how to use a data binder programmatically to invoke validation logic after binding to a target object. Foo target equals new foo, data binder equals new data binder target, binder.set validator new foo, validator // bind to the target object. binder.bind property values / validate the target object. Binder.validate / get binding result that includes any validation errors. Binding result results equals binder.get binding result. You can also configure a data binder with multiple validator instances through databinder.add validators and databinder.replace validators. This is useful when combining globally configured bin validation with a Spring validator configured locally on a data binder instance. See Spring MVC validation configuration.